Our first example for graphing circles, example A, asks us to graph the equation x squared plus y squared equals 9. So we're going to use our standard form, which was r squared equals x minus h squared plus y minus k squared. And remember that our center is at hk, and that our radius is r. So r squared then would be the number out by itself. So 9 represents r squared. So if we take the square root of 9, we get 3. So 3 is our radius. So our circle is going to be 3 units in each direction from the center. And the center is represented by the numbers that are subtracted from x and y. Now in this case, we just have x and y. So our center is just going to be 0, 0. There isn't anything subtracted from either one of them. So our center is right here at the origin, and our radius is 3 units in each direction. So we go 1, 2, 3, 1, 2, 3, 3, and 3. And then we fill our circle in with that section in between. Let's see if I can actually draw one with a tool here, since usually my circles leave a lot to be desired. There we go. That's much better. So pretty easy to draw once we have the right information. All right, let's take a look at example B. Example B says find the equation of the circle below. So this one we're working the other direction. This time we have the circle, and we're going to try and find the equation. So the first thing we need to do is locate the center. So we're just going to draw a line that goes all the way across the diameter of the circle, and then another one that goes all the way across the diameter of the circle. And just to make sure we have the right location, we'll go ahead and do a third. And where all those lines intersect is the center of the circle. So this looks like this intersects at 3 on our y-coordinate and negative 3 on our x-coordinate. So our hk will be negative 3, 3. And then from that point, our radius is 1, 2, 3, 4, 5, 6 units. So r equals 6. And now remember, our standard form is r squared equals x minus h squared plus y minus k squared. So first we have r squared, that's 36, and it's equal to x minus negative 3, so that would be x plus 3 squared, plus y minus 3, so y minus 3 squared. And there we have the equation of our circle in standard form. And then example C. Example C says determine if the following points are on the circle x plus 1 squared plus y minus 5 squared equals 50. So we're going to have a circle that looks like this. It has a point at x minus h, so negative 1, y minus k, so 5. So it has a center right about here, and then it'd be 7 units in each direction. So our circle would be out here, sort of generally in this area. Again, sorry about my artistry, but we'll get the general idea there. So what we're looking for then is to see if these 2 points, 8, negative 3, and negative 2, 2, are actually on that circle. Yeah? So we'll just take our 2 values then and put them into the form of our equation, and then we can actually solve to see if those points are mathematically in that circle. So let's go ahead and move this out of our way here, make a little room, and we'll do, using our equation here, we'll put 8 in for x and negative 3 in for y. So we get 8 plus 1 squared plus negative 3 minus 5 squared equals 50. So if this works out, then this point is one of the solutions for this equation, and this point then represents a point that's actually on the circle. So we do 8 plus 1, that's 9, and 9 squared is 81. And we add that to negative 3 minus 5, that's negative 8, squared would be 64, and that needs to equal 50. Well, obviously 81 plus 64 is not going to be anywhere close to 50, so point A is definitely not on the circle. Now we can try B. We'll have B would be negative 2 for x, negative 2 plus 1 squared, plus, and then negative 2 for y, negative 2 minus 5 squared equals 50. So we have negative 2 plus 1, that's negative 1, squared would be 1, plus negative 2 minus 5, that's negative 7, squared would be positive 49, equals 50. And yeah, 1 plus 49 is 50, so B is indeed on that circle, that point negative 2, negative 2. We'll put our little xy graph back out there for just a second. Why am I getting, oh yeah, we'll go up here. Negative 2, negative 2. This point is actually on my circle, so you can see my sketch wasn't very accurate. Now there's a big surprise, I know. But that point right here is actually on the circle if we were to graph it accurately. There we go.